So we have two different methods of measuring the pH of a solution. We have method A here, and we have method B. And we're interested in finding out if method A gives, on average, the same results as method B, or if there's a significant deviation between the means of the pH measurements of the two methods. So what we will do is that we have 10 test tubes here with the solutions in each. The solutions don't necessarily have the same pH value. That's important to say. What we will do is that we will take a little bit from test tube 1 and measure the pH using method A, and we'll take a little bit of test tube 1 and measure the pH using method B. So that gives us two measurements. The first one is 1.503 and the other one is 1.516. And then we continue with the next test tube and we do the same thing. And we get two other numbers here and so on. Now, once we've done that, we have two samples. We could call it sample A and sample B. We would like to compare the means of these two to see if they're the same. So what we're testing is not whether these test tubes have the same pH value, but because we know that the pH of one is the same in each case. But what we're testing is the methods. And the best way to do that is to generate another sample, which is the difference between the two measurements. I'll call the difference capital delta here. And the reason we can do that is because there is a relationship between this number and this number, namely, and the relationship is obvious, they come from the same test tube. So we subtract the two numbers and write the result here. And the same thing for these two numbers here, we write the difference here. And once we've done that, we end up with a new sample. I'll call it sample delta. And that's the sample we will actually conduct the test on. And that results in a one sample t-test. And we know that one. T-test on the differences. So our null hypothesis, well, typically we would hypothesize that the two methods produce on average the same results. So the null hypothesis would be that the difference, the mean difference, is 0. And the alternative hypothesis could be that the mean difference is not 0. But notice that we're only using this difference sample here, the 10 differences. The reason that's a good idea, I mean, we could do a two-sample t-test on these two, sample A and sample B. But if we do that, then we include a lot of variance coming from the differences between the pH values in these test tubes. That would clutter the result. It would make it more diffuse and not very precise. Because we're not really interested, actually we're not interested in the pH value of test tube 1 and test tube 1 in these cases. We're only interested in the difference. So by subtracting those two from each other and doing the same for the next one and the next one, we can sort of exclude the variance that exists between the test tubes here, which is of no interest to us. Okay, so the test statistic here is, as we know it, it's the mean of the difference sample minus the hypothesized mean, which is 0 in our case here, which it often is, divided by our sample standard deviation divided by the square root of the sample size. And that has a t-distribution with n-1 degrees of freedom. So let's try to do this in Excel. So here we have the 10 measurement results from each method. And the first thing I'll do is I'll compute the differences, taking method A measurement minus method B measurement, and let's make a copy of that. So there we have our difference sample, and we start by computing the mean, difference mean we could call it. I'll expand this column a little bit, and that's just, well, you need to write average in English, I'll write mid in Danish. So that's the mean of the differences. We also need the sample standard deviation. So you write something like STD DEV for deviation, and you need to choose the sample standard deviation, not the population standard deviation here. There you go. And the number of observations in our sample is 10 in this case. So now we can compute the test statistic. And that's the mean of the differences minus the hypothesized mean of differences, which is 0 in our case, divided by the sample standard deviation divided by the square root, SQRT in English, of the sample size, like that. So that's our test statistic. So let's compute the p-value. We can see the test statistic is quite large numerically speaking, so we expect that we might be able to reject the null hypothesis. And we write 2 times 1 minus, and then we need the t-distribution in Danish, take-fordeling, like that. And we input the sample size, or the test statistic, or rather the absolute value of the test statistic. So I need to write ABS here, like that. And then we pick the number of degrees of freedom, and that's n-1. And then we select true, or set in Danish, because we want the cumulative distribution. Oh, I forgot something. Like that. Yes, I believe that's right. So we get a p-value of a little bit less than 1%. So if we have a significance level of 5%, that means we can reject the null hypothesis. In other words, we have statistical evidence to say that these two methods produce, on average, different pH values.